Hey everyone, what we're going to be learning about today is a product rule, so go ahead, let's get this copied on your notes. For multiplying monomials, we've talked about monomials before, but to multiply monomials, there's a couple different ways you can do this. You can factor, which means expanded notation, or you can use a product rule. So if we're going to factor it out, we're going to take our knowledge of expanded notation, or basically we're factoring each of the bases out to factor each term, and then you're going to count how many of each variable you have, and each variable is a different base. So just like when we're combining like terms or doing our exponents, the total number is the same base will be your exponent. So I'll show you what I mean by that in a minute. And then if there's any coefficients, you're going to multiply the coefficients based on the operations that's happening. And then if in case in doubt, factor it out. So if you totally forget what we're going to product rule, factoring is always a great backup plan. All right, here's what we're actually going to be learning about today. We're going to be practicing the factoring, but the product rule is what this is all about today. So what you're going to do is, if you notice, we have the same base of x and x, and then we're actually multiplying. So if you notice, we're multiplying the same base. So since we are multiplying the same base, you're going to keep the base the same as x. And then here's the cool part with the product rule, is you take the exponent of one base, and you take the exponent of one term, and then you take the exponent of the other term, and you actually add the two together. So it's kind of a shortcut to factoring, but when you're multiplying the same base, you add the exponents. So this is the product rule, but it has to be the same base, and you have to be multiplying. So if you're multiplying the same base, add the exponents. If they have different bases, you cannot multiply the exponents together, or you can't add the exponents together. They have to be the same base. You can add the exponents. So we're going to go ahead, we're going to do some of these together, and I'm going to show you both ways of factoring and product rule. So let's get started. So for factoring, we have 3 to the 4th and 3 squared. So what I'm going to do is I'm going to take this first, and I'm just going to make this purple. And this just means you're writing 3 4 times. And remember, we are multiplying, because remember, it's 3 times 3 times 3. And then we're going to take the other one, and I'll make this one pink. And we have, and remember, we're still multiplying, 3 times 3. So you notice 3 squared, you wrote 2 3s, and 3 to the 4th power, you wrote 1, 2, 3, 4. So now, if you were to combine all those together and go 3 times 3 times 3 times 3 times 3 times 3, you're actually going to get 3 to the 6th power. So that's how you would factor it, is just by writing it all out. Now the product rule says if you're multiplying the same base, so here the base is 3, you add the exponent. So you keep the base the same. Do not write 9. Do not write 9. But what you're going to do is you're going to go 4 as an exponent plus 2, and then you write those together, and you're going to get 3 to the 6th power. So notice we still get the same thing. We just solve a little bit differently, but it's still the same way. So the product rule is basically a shortcut for your factoring. So let's go ahead, let's do this next one. We got x squared, so it's x times x. And then I've got x to the 3rd. So remember, we're still multiplying. And then you're just going to count all of them out. So you have a base of x, and then just count how many x's you have. You have 1, 2, 3, 4, 5. So it's x to the 5th. Or you can do the shortcut, where you write the base and you add the exponents. Oops, looks like I did. I'll do this pink. I actually did the other color. Wheel then. Okay, we'll do yellow. That's what I meant to do on the other one. All right, and then we'll do pink on this one. That was my bad, I wrote the wrong ones. Okay, so now we go 2 plus 3, and that you're still going to get x to the 5th. Alrighty, and I'm going to write this 2 in purple. There we go. All right, so we still get the same thing. It's just a shorter cut. All right, so now on this next one, I want you to make sure you write this on your paper off to the side. if you look at a to the 9th power times a, if you notice, a to the 9th has an exponent of 9, but a does not have an exponent next to it. So if there is no exponent, it is understood that your exponent is 1 because you have to at least have it written once. So that's how you do that. And then truthfully, I always write the 1 in so I don't forget when I'm combining using my rules. So now let's go ahead, let's do the factoring. And if I were to do this first one, and I'm going to use a right color this time, let's go with yellow. I'm going to write this 9 times. 1, 2, 3. That was fun. All right, and then we're going to do pink on the next one. So I am going to write times a. And then again, if you add all your a's up because you're multiplying, you should have a to the 10th power. All right, and the shortcut for using the product rule is if you go a to the 9th times a, and I always write in that, you're going to get a to 9 plus 1, which equals a to the 10th. So we got the same thing. All right, I'm going to go a little bit faster on these next one. And I'm not going to color code, but if you do need to color code, feel free to go back. So we got 1, 2, 3, 4, 5, 6, 7. So that's this guy. And then times. Oops, ran out of room. So now that I've got that, I should have w to the 11th power. All right, and then the shortcut here is take your base, and you're going to go 7 plus 4, which is 11. So once you get the hang of this, is you don't have to factor it all out. But if you ever get stuck, factor it out and then count it. Now we're going to get a little crazy, not too crazy, but a little crazy. Now what we're going to do is we're going to take our first term and we're going to factor it out. So you can leave the 4 as is, and then that's 4 times x. And then we're going to take this term, and then that's actually times 3 times x, 4, 5. So what we're going to have to do here is we actually have to multiply the coefficients. So because 4 and 3 are not like bases, so we're just going to multiply these guys together. So 4 times 3 is actually going to equal 12. And then now we can just go ahead and we can count all of our 1, 2, 3, 4, 5, 6, 7. And then this is simplified. All right. Now when we're writing it this way, we're going to kind of move the 4 times 3, and then we're going to go, because that's times x squared plus 5. So again, remember, we're multiplying throughout the whole thing, so you're still going to get 12x to the 7th power. So same thing, just slightly different way. But remember, if you have different bases, you're going to multiply those together to get that. All right, now we're getting a little crazy, a little bit crazier. Now, first thing I like to do is I look at everything. So I've got a negative 4 has an exponent of 1, A has an exponent of 3, B does not have an exponent, so I'm going to write a 1 in. Same with 3, 3 has an exponent of 1, and then we're going to go from there. So we're going to combine our coefficients, which are negative 4 and 3, and we can just multiply those together because they're numbers, and we don't have any other bases to work with. So we've got negative 12. And then now let's go through and let's factor out our a's. So I've got 3 here and 2 here. Okay, now let's look at our b's. I've got 1 here and 5 here. So 1, 2, 3, 4, 5, 6. And then if you put it all together, you get negative 12, a to the 5th, b to the 6th. So again, I always add the 1 just in case. And then now let's do the shortcut. Now we're going to go a 3 plus 2 and b 1 plus 5. So again, remember we're multiplying our coefficients together. And then a to the 5th, b to the 6. All right, lastly, for our examples, don't be scared. We've got a whole number and we've got a fraction. It's still the same thing. So you're still going to multiply those guys together. So it's 12 times 2/3. And remember, that's technically 12 over 1. So I like to cross simplify. And then that's actually 8. So we're going to get 8 as our coefficient. And then now let's count our y's. This y does not have an exponent, so I'm going to add an exponent there. And this x does not have an exponent. And technically the fraction in that they don't have exponents either. So I'm going to go in and add 1 as an exponent to everything. And now let's start counting. Well, I only have 1x, but it looks like I have 1 y here times 4 more there. And put them all together. And technically, remember, you put this in alphabetical order, so the x should go first. And then you should have 5 y's. So that's the factoring it out. And then if you come over here and do the shortcut, it's 12 times 2/3. And then you're going to do x, and I'll just put a 1 here. And then y's, we've got y 1 plus 4, and then put it all together, and you've got 8x, and we typically don't write the 1 unless we're, when we simplify it, so we don't write the 1 when we're simplifying. And then that's it. All right, so what you're going to do is you're going to do 1 through 9. I want you to try those, and you can do either method, factoring or use a product rule. I would definitely try both. You don't have to do both for each one though. But lastly, here's this. Again, this looks kind of crazy, but we can do this. So what we're going to do is we're actually going to take our product rule and we're going to be adding, subtracting monomials too. So we're going to put it all together. So first, what we're going to do is we're going to simplify this section. Then we're going to simplify this section, and then we're going to add them together. So think of order operations. You're doing your multiplication first. All right. So now let's go ahead. I like to add 1s to anything that does not have a 1. All right, now let's go ahead and let's multiply. I've got 2 times 4, which is 8, and then I'm going to do, and I'll use yellow. Now I'm going to do x, 5 plus 1, and then now I'm going to do, I'll do a different color since I already did that one. For my y's, I'm going to do green. Okay, so then when you go ahead and simplify this part, you get 8x to the 6th, y to the 5th. All right, and then now we're going to go ahead and simplify this other part here. So the only coefficient I have is 3, so I'm going to write that first. And then now let's look at our x's. I've got a here and here. So you should get x 4 plus 2. And then now let's look at our y's. I've got 4, and don't forget that 1 there. That is a common mistake. And then now let's put it all together. 3x to the 6th, y to the 5th, and then don't forget to add. So now let's look at this. If you're to look at all of this, notice these are like terms because they have the same variables and the same exponents for both. So now all you have to do is just add your coefficient of +8 and +3, and you get 11. And then you do not, since we're adding in between, do not change the exponents. You only change the exponents when you're multiplying or dividing. Do not change the exponents when you're adding or subtracting. And that's your answer. So I want you to try this next one with 11, and you can do that. So remember, use the product rule, simplify, then combine like terms. So remember, if you're multiplying the same base, add the exponent. If you get stuck, factor it out. But remember, product rule is whenever you're multiplying the same base, you're always adding your exponent.